Alright, welcome to Chapter 10, Section 8, Proving Angle Relationships. This is for Integrated Math 1 or IM 1. So the first couple things you're going to see on your screen would be the due date. I don't see that on my teacher preview, but you will see it on your student screen. The second thing is the number of attempts. We always have unlimited attempts on homework, tests, and quizzes. Number of questions just tells you how many questions are on this particular assignment. Grading policy is always best score, so whichever attempt is the best one is one you get to keep. Partial credit is enabled, so if you answer one of 7 questions correctly, then you get to keep credit for that one question, or however many you answered correctly. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. What that means is once I click the Start button, down here in the bottom right corner, you will see a Submit Assignment button. This is how we finish an assignment, is by clicking this button. So 2 huge reasons to click this button. Number 1, just like that last screen said, you can't work on anything else until you click that button, until you finish your assignment. What Alex will do is it will lock you out of all of your other assignments. If you just close this screen or close your computer without clicking the Submit Assignment button, it assumes you want to leave this attempt open, and it will lock everything else out, including resources. Just make sure you always click that button. It will save your place, so you're not going to have to start anything over. If you have a green check mark here, it's going to save that. Definitely knows where you've been. If you've typed things in here and you have not clicked check yet, it does not save that. So make sure that you click the check button to get your credit. So big reason there, don't get locked out of your other assignments and resources. The second big reason is that it actually updates the gradebook when you click that button. So until you click Submit Assignment down here in the bottom right corner, your account is basically frozen on that assignment. We can't see what you've been working on. So 2 big reasons there. Make sure you click that button before you leave this screen. All right, now let's look at the side here. We have it wasn't popping up there. Explanation, example, and message center. So explanation tells us we're going to lose our current question attempt because it's going to give us the answer or solution to this question. So it's not going to give you the answer and then let you come type it in. Example will give you something very close to what we're looking at. So it'll kind of give us the background on what complement and supplement actually mean, and we'll write that notes over here in just a minute. So you can look through this and see an example. You can click an example again to see another one. You can also message your teacher directly from the screen. It attaches a picture of what you're working on so we know where to come help you. All right, so let's go ahead and get started over here. And I'm going to change the color because I don't like the red. So it says an angle measures 45 degrees. What is the measure of its complement? An angle measures 104 degrees. What is the measure of its supplement? So we have some definitions here. We need to know what complement and supplement mean. So we have a complement is when I have a 90-degree angle, and they don't necessarily have to be together like this, and I'll use red for this one. So we have 2 angles, and if I add them together, they get 90 degrees. So that's all complement means, is 2 angles that add up to 90 degrees. Do they have to be together? No. I could have, and I'm going to try to draw this guy like this. So I'm trying to match that one, and then I could have this other one separated, so it's these 2 angles, so I just separated them like this. You can have them separate too, but a lot of the time we see them together as a 90-degree angle. So if 2 angles add up to 90 degrees, we call them complements or complementary. If 2 angles add up to 180 degrees, which we also call linear angles if they're on the line together like this, so this is complement. I forgot to write the word complement. I said it, but I didn't write it. Complement. And this is a supplement or supplementary. A lot of the time we put the A-R-Y on the end, but either way means the same thing. So they add up to 180 degrees, or they're on one line together, so they're a linear pair. Again, they can be separated. They do not have to be on one line together. You can have this kind of obtuse angle here, and then you can have the other angle completely separated like that. So they don't necessarily have to be together. All they have to do is add up to 180 degrees. Okay, so that's complement and supplement. So using those 2 definitions, we're going to figure this out. So if we have the angle measure 45 and we want to know what is the measure of its complement, well, if this is 45 degrees here, I want to know what's this one, right? So I'm just using that idea. And so I'm going to go 90 minus 45, because remember they have to add up to 90. So I'm going to subtract what I'm using to see what's left over. So I have some borrowing to do there, and I get 45 again, because 45 plus 45 is 90, right? All right, So the second one, now my angle measure is 104, and I want to know what its supplement is. So I'm saying that this is 104 here, and I want to know what that guy is. So they have to add up to 180 degrees. So I'm going to subtract what I'm using, which is the 104, and see what's left over. So I have some borrowing again to do here. So I get 7 and 0. So 76 degrees. Boom, boom. All right. So it's kind of an introduction to complement and supplement. It should be kind of a review. I know we've heard these words before. We deal with them in 8th grade as well. So it's definitely something that we should have heard before. It hopefully it's just a review. So we're still using this same idea here. And I think I've seen this same one where it's also a complement instead of a supplement. So this is a straight line with 2 angles on it. I have to understand which one I'm using. They have to add to 180 because they're on a flat line together. If I saw a diagram that looked like this one up here, then I'm going to have to make sure that I know, okay, they add up to 90 degrees. So this one requires you to think about it. Which of the 2 am I using? So with this one, I have this guy here, something like that. And they're telling me that angle 1 is 145. So very similar to what we just did with the 104. I want to know what that one is. So I'm going to go 180, and I'm going to subtract what I'm using. And you could actually write this out as 145 plus x equals 180. And you're going to subtract 145 from both sides to get x by itself. So you could write this out as an equation as well if you want to. All right, so we're subtracting. So we get 5, I get 3, and 0. So angle 2 has to be 35 degrees. And if you notice, this is not drawn to scale. This is not a 145 degree angle. This is definitely not a 35 degree angle. This is much more like a 60 degree angle. So they didn't say anything about this not being drawn to scale, but don't trust the diagrams unless they tell you to trust the diagrams. So quite literally, unless they're giving you a protractor to measure with, I would not trust the diagram. It's just something to look at. It's a visual, so I can draw it out and fill it in, but it doesn't match up with the actual angle measures. It's just a diagram. So just be careful about that. It's not meant to be accurate in that way. It's just meant to give us something to look at so we can visualize the problem. All right, so, perfect. So this one, we do have that same idea, but now we're doing the 90 degree angle. And I can see this little square here. That means that it's a 90 degree angle. So that tells me that's what I'm going to do with that. So I have angle 1 is 4x. So angle 1 was on top. And then angle 2 is x minus 5. So I'm going to have to write an equation for this one because I can't simply just subtract what I have for angle 1 to figure out what's left over because they both have a variable in them. So I know if I add these two together, like I talked about on that last one, you can add them together. They have to add up to not 180, 90. This one's a 90 with that little square. So now I can combine like terms. I have 4x plus 1x, so that's 5x minus 5 equals 90. So now I'm going to start doing solving my equation. You always want to do addition and subtraction first, mainly because it's easier. You can actually do multiplication and division first, but a lot of the time we end up with fractions, and we don't like that. In this case, we wouldn't actually end up with fractions. Everything's divisible by 5, but I don't suggest you doing that first. A lot of the time we end up with fractions. It's just a little more complicated. If we do our addition subtraction first, it tends to simplify the process. So 5x comes down. If you notice, I didn't write anything here because negative 5 plus 5 cancels out. And then we add 5 there and we get 95, and we're going to divide by 5 on both sides because I want to get rid of that multiplication. 5 divided by 5 cancels. I have x equals, and so in this case, let's see, 95. So it goes in once with a 4 left over, and it goes into 45 9 times. All right, so that's 19. Woo! Go back. Let's see. Zoomed way out on me. I don't like that. Okay, so I have 19 equals, or x equals 19. That's not one of my answers. Neither one of these is just x. So I need to go back over here and say, okay, well, it's 4x. So it's 4 times 19. And this guy is 19 minus 5. So I need to work both out because they want to know what is angle 1, what is angle 2. I needed x to figure that out. But x is not one of the answers I'm going to type in. So be careful about what it's asking you. Make sure you're paying attention to that. So with this one, let's see, 4 times 9 is 36. 4 times 1 is 4, plus 3 more is 7. So angle 1 should be 76. Angle 2, if I subtract 5 from 19, I get 14. And if I take a look at these, if I added these back together, I would in fact get 90, because I get 10 here, 7, 8, 9. And again, these angles do not look quite right to me. They, may be a little close, but this is definitely, I don't think this is a 14-degree angle. A little bit small, or a little bit big actually for a 14-degree angle. All right, let's go to the next one. Okay, so we're going to get away. I'm going to take these notes away because we're going to start noting something else here. So with this one, a lot of the time we have parallel lines, and I think they're going to move to parallel lines. So I'm going to go ahead and draw them as parallel lines. And I'm going to draw them kind of crooked so you can see like these two are specifically my parallel lines. Now in this one, all we're doing is looking at the naming. We don't actually care if the two lines going kind of in the similar direction are parallel. The names are still the same. What's going to change when we move to parallel lines is the relationship that it creates. So when we're talking about lines and transversals, I'm going to turn this off. This is called a transversal. Transversal. And it kind of means if you transverse something, it means you've walked across it. You can use that wording. It's not a very common word, I don't think. But it, I've heard it before. So with this one, it just means that it's crossing the other two lines. That's what transversal means. So it's a line that's crossing the other two. If you notice, they don't give us the different color coding. We have to identify the line that's crossing the other two. We have to kind of do that ourselves. And these other two don't really have a name. I made them parallel, but these guys, you can definitely tell these two are not parallel. If I kept drawing these lines across, they would definitely intersect, somewhere over here. So they're definitely not parallel in there. I don't think mine are perfectly parallel either, but they're closer. So these ones don't really have names to them other than the names they give them here. So this is line L, this is line M, and they tend to do these little cursive-y type things. And this was line N. So line N is crossing line L and M. That's how I know it's the transversal. It's crossing at least two lines. And then we have all of these pieces in between. So this creates certain relationships that we need to, understand here for sure. So let's see, I'll grab bright blue, why not? So vertical angles, this is not created by lines and transversals. A vertical angle is created anytime we have two lines just crossing. So anytime you have an X pattern like that, it doesn't matter if it's, a skinny X or kind of a wider X like that. I think that looked a lot like that one, but so it can be, kind of skinny like that. It doesn't necessarily matter how the X pattern is created, or it can even be a little bit crooked. So it doesn't have to be kind of a straight up and down X like this. It can be sideways anytime two lines cross. What we can do is we can go across the vertex, so opposite, do that a little nicer like that, and the two angles that it touches are congruent. So vertical angles are congruent, and this is the congruent sign, an equal sign with a little wiggly above it. So anytime we do that, and I can go sideways like this, and I can go this one, and this one are congruent. And I'll use two lines here because these two are not going to be congruent to these two. That's not a promise. But they are congruent to each other across. I could even go this way as well. Well, I did that a little sideways, this way as well, and I can go, these two are congruent to each other, like that. And so these guys, 1, 2, 3, 4. 1, 2, 3, 4. So the number of arcs match up. When you have more than one angle congruent, you can use more arcs. So this is getting a little bit busy because I'm using a lot of arcs there. But you want to be careful about just using different colors, because if, your page was printed in black and white, that takes the colors away. So immediately the kind of key is gone. Or by chance, if someone was looking at it that couldn't see color, or couldn't see that color, then maybe they wouldn't see the difference between the ones. So you just want to be careful about just using colors when you're doing that. The number of arcs definitely helps us with that. So this is a vertical angle. Does not require anything to do with two lines and a transversal, just two lines crossing each other. Then we have a linear pair. Again, has nothing to do with parallel lines or the transversal. Linear pair. We're just introducing the idea here, so we're going to keep this one and we're going to build on it in a moment because there are a lot of relationships that come out of this situation here. So a linear pair is when I have a line, and actually it's going to be kind of the same thing, two lines crossing, and what I'm doing is I'm going to focus on the two that are across the same section there. So they add up to 180 degrees, like that. Or I could go, from this one to this one like this. So as long as it's two angles that are on the same line together and they fill up the entire line. So it couldn't be something, like this angle and this angle like this, and then I would just stop here because they're on the same line together. It would have to be all three angles, and it wouldn't be a pair anymore because there's more than two there. There would be this third one also. So we want to be careful when we're looking at that. It's two angles on the same line that fill up the entire space there, going from one side of the line to the other. So just in this one little drawing, when I have this X pattern, I actually end up with, go like this, I end up with 4 different linear pairs, and hopefully I know that's starting to look a little bit crazy, going like that. So I can go from here to here, so these two, the yellow is the top right and the bottom right, the pink is the bottom right and the bottom left, and the green is the bottom left and the top left. So hopefully that direction kind of made sense, but I can keep moving around here and complete that. So I can have a linear pair here, or I can have linear pairs here. So if each one has 4 options, I have 8 different options on this diagram to choose from. And with vertical angles, I have 2 options kind of per crisscross. So I have 4 different options to choose from for a vertical angle. So there is more than one answer to this question, definitely. It definitely works out that way. Supplementary angles, so that's just kind of going back there. They might ask you for supplementary or congruent. I've seen both questions on this type of problem. So supplementary goes back to they add up to 180 degrees. If they ask you for a congruent angle, then you're going to come over here and focus on the vertical angle. Which ones are vertical? We know those are congruent. Those are the only relationships we know about right now that are congruent. And for supplementary, the only thing we know about right now is linear pair. So if they ask you for supplements, you can type in the exact 2 angles that you typed in for linear pair. If they ask you for congruent, you can use the same 2 angles you did for vertical. Or you could use different ones. You could use other vertical angles because remember there's 8 options, or 4 options total for vertical and 8 options total for linear. All right, so let's go ahead and type some stuff in here. So I'm just going to start at 1 for vertical angles, and I'm going to go to 4. So 1 and 4. 1 and 4. I could have gone 2 and 3, 5 and 8, or 6 and 7. A linear pair, so if I go back to 1, I'm going to go 1 and 2. 1 and 2. Again, I could have gone 1 and 2, 2 and 4, 4 and 3, 3 and 1, or I could go down here and do the same thing all the way around. So there's a lot of options on this guy. And then supplement, since I know linear pairs add up to 180, I'm just going to use those same 2 angles. Why not? All right. So, and this one is asking us to apply one of 2, or both actually, both of these relationships. So vertical angle and linear pair, and I'm just going to erase that guy. So if I have this one here, and it's telling me that angle 4 is 127 degrees, and it wants to know what angle 1, 2, and 3 are. So anytime I have lines crossing, I can use both vertical angle and linear pair. So the easy one to start with is vertical angles, because I can just go across, and they have to be equal to each other. So I know angle 2 is going to be 127 degrees. So without doing any calculations, just understanding that definition, I know what angle 2 is going to be. Angle 3 or angle 1, I can kind of make my choice. So I guess I'll do angle 1 first here. If I go across like this, from one side of the line to the other, they have to add up to 180 degrees. Those are supplements or a linear pair. So I can say, well, if they have to add up to 180 and I'm using 127, what's left over? So I'm going to subtract, and I'm borrowing, and I get 7, and I get 5, and that would be 0. So this is 57. I could also have gone the other way, like this. And if I'm subtracting 127 from the same 180, I'm going to end up with 57 here as well, because it would be the exact same calculation. Notice these are also vertical angles. So once I know this is 57, the one opposite will also be 57. So a couple of different ways to solve that last piece once we have it. And if for some reason you didn't use vertical angle to do angle 2, you could have done the supplements to go, either to 1 or 2 or 1 or 3, and then done supplements again to go from either 1 to 2 to 3, 3 to 2 or 1 to 2. But vertical angles does not go away. It's very easy to use, and it's going to come up pretty often. So I would definitely get used to that one, because we're going to use it a lot. What did I calculate wrong? 57. Oh, why did I write 7? This would be a 3. I'm a crazy person. I was, for some reason, bringing down the 7 from the 0, but that should have been 10. Okay, now it should be good. Yay! Okay. All right, so we have another vertical angle, or just two lines crossing each other. So I'm trying to remember, are we actually going to use the angle measures for this guy? This might be on the next section, actually. They just started to introduce what this looks like. So we have z and x minus 98 and 5x minus 2. All right, and so it wants us to find the value of x and z. So z is an angle all by itself, but x is not. So with this one, it kind of depends on, what I see first. So I can see that these are vertical angles. So these would be congruent to each other, but that's not terribly helpful to me to write 5x minus 2 is equal to z. Sorry, I crossed my z's because you can tell they kind of look like my 2's. Well, I can't really solve for one variable or the other. I have two variables there. So I don't really want to use this one because I can't solve for one of my variables. So what I want to focus on is, and I'll go bigger, these two angles here. They are a linear pair, and I only have x in them. So I can say 5x minus 2 plus 9x minus 98. They're a linear pair, so they have to add up. So I put the plus sign here to 180. I can't just simply subtract what I'm using from 180. I have to write out some little equation like this because I have the expressions that I have to deal with. So I'm going to add my like terms. 5 plus 9 is 14x. And then negative 2 minus 98. I have negative 2. I'm going another 98 negative, so that's negative 100. I add them together and keep the negative sign. And I get 180. So now we're kind of in a more normal situation with our equation. We've reduced it down to a lot of the time where we start equations, or when we're at least starting out equations. So we're going to deal with addition, subtraction first. So I'm going to add 100 to both sides. Boop. And I have 14x. 100, negative 100 plus 100 cancels. And I get 280 here. And then I'm going to divide by 14 because I'm multiplying. So again, we always want something to eliminate or cancel out. So we have x equals, and they do give us a calculator here. I don't know this one. Ooh, I do think I know this one right off the top of my head because 28, why is it not typing in? It's arguing with me. I can actually kind of think about this one as far as 28 divides by 14 2 times. So then I'm pretty darn sure we're going to end up with 20 here because it would be 2 times for 28, 0 times for the 0 there. So perfect, 20. So, oh, what in the heck? Why did it start to turn? This silly control system. All right, so we get 20 for x. So I know what x is. Now I need to go back and find z. So now I can go back to that vertical angle idea that I had, and I know that these are congruent. So if I plug in x really quick here for this side, and figure out what this angle is, then that's going to be the same thing for z. So 5 times 20, well, 2, 4, 6, 8, 10, right? That's 100 minus 2, so that brings me to 98. So I end up with 98 degrees on either side because it's going to go across there. All right. Perfect. All right, so I'm going to go ahead and erase this diagram because we'll come back to that on another topic here, I'm assuming. So proofs, we're just starting to be introduced to proofs here. And there are definitely, some cute ways that we've talked about proofs in class. Hopefully you got to do the getting dressed activity because that's definitely a very cute way to think about the process of something because we all, get up in the morning and we have to get dressed for the day before we leave our house, right? So it was one worksheet that I had in the notes pages where, it listed a jacket and a shirt and pants and shoes and socks and, your undergarments, things like that. And it had students go through and decide in which order would you put these on and why. And you have to think about it because, would you put your shoes on before your socks? No, of course not. Would you put your jacket on before you put your shirt on? I hope not, because you're going to have some issues there. So, but if I put my, pants on and then my socks on, is it going to matter? Or if I put my socks on and then my pants on, does that matter? It doesn't actually change the order. The outcome doesn't matter as long as both happen, but they're not dependent on each other. But shoes and socks would kind of be dependent. I need the socks before the shoes. Or jacket and shirt, that's dependent on each other. I need the shirt before the jacket, right? So same thing with the proof. It's just kind of a easy way to think of that idea. There are some things within a proof, and a proof just means that we're going through step by step. How do I get from what I'm given, the beginning, to what they're asking me to solve or prove here? And so we're going to think of it kind of the same way as that getting dressed idea. What steps do I need to take to get from the beginning to the end? And is something dependent on the other? So we definitely want to pay attention to that. And I kind of like to take a picture here and put it on my little piece over here so I can actually kind of mark it up. And I like to plan it out, kind of think about it before I start planning or before I start writing in the statements and the reasons here. Because it makes it a little easier to, run through the problem if I've already started to think about it. So we're going to use the information to prove that angle 2 equals the measure of angle 3. Sorry, I forgot measure of. So when we use measure of angle instead of just angle, it means we know that the measures are congruent. So if we actually, took a protractor out and measured them, don't do that on this diagram. We're assuming that the diagram is not actually correct. But the measures are the same, so the degree angle is the same. We're not just talking about the geometric figure of an angle, which is why we don't just use angle. So just silly differences there, but they do matter. Definitely in Alex, it will mark you wrong for things like that. So, I said silly little things, but they're very specific when we're talking about these things. You need to make sure you're using the correct terminology and the correct symbols. Because if you notice over here, you have both. So you have to know which one to choose. Since we're starting with measure of, we're going to use measure of throughout the whole thing here. All right, so it says given the measure of angle AEC, so I have AEC, so this one here, is equal to the measure of BED. So I'm going to just change my color up and go BED like this. So I have these two congruent to each other. And they want us to prove that angle 2 and angle 3 on the outside here are congruent to each other. So when I'm looking at this, the first thing you want to think of, is there anything that they're sharing? Because a lot of the time these diagrams are sharing something, meaning they're sharing a line. If I kind of separated the diagrams, would they be the exact same line on both diagrams, or are they sharing an angle? And in this case, if we notice right here, there's blue and there's red. This angle is being, and I'm not doing really good here. I'll turn on my line tool so that comes out a little bit better. So these two angles, or this one angle here, is actually shared in both the givens. It has a blue and a red in it. So that is a shared angle. That's something that we definitely want to make sure that we clue in on here. We're also going to have to kind of run through all of the different things that we've learned up to this point. When we start working in the geometry sections, there's a lot more to remember as far as reasons. And I'm going to click on here. So we have this list. It's not a huge list yet, but we have to know, was it given to us? We only have one given, so we only use that reason once. Reflex property means something is equal to itself. So that's why we wanted to look, is there, something that they share, because we can probably use reflex property. The addition, subtraction, or multiplication, division properties, that has to do when we're looking at things more algebraically, which we actually, I think we'll use that one on this proof here. Substitution is when we substitute one thing for another. So if I know that one is equal to another, then I can substitute that piece together, or substitute one for the other. Definition, congruent segments. We don't have any segments on this one, but you might. It kind of depends on the diagram they give you. Since we're working with angle relationships, I don't think they're going to give you segments on this one, but they could for congruent segments. Segment addition property means, if I have a segment like this, segment, boom, boom, and then there's another point somewhere in the middle, I can add the two pieces together to get the entire segment. So, if I know that this is 9 and this is 5, I can add it together and I get 14. Or if I know that the whole thing is 14 and this one's 9 and I had x over here, I could subtract and go, oh, okay, well, this one has to be 5. So that's segment addition, is that idea. And then we have definition of congruent angles, which, we may very well use that one here as we plan this out. Congruent angles, if I know that two angles are equal to each other or congruent, then they are equal. A lot of the time we use that from when we want to go from the congruent symbol, like this angle is congruent to this angle, I use definition of congruent angles to change it from congruent to equal, because that is the definition. If they are congruent, they are equal. But they mean different things, equal and congruent. Equal has to do with the measurement. Congruent has to do with the size and shape. So there are different definitions. They do mean the same thing. If something is the same size and shape, it's going to be the same measurement. But we use them in different ways. And then angle addition property. So this is definitely what we're going to use here. So if I have an angle and it's divided into two pieces, I can add the two pieces together to get the whole angle. All right, so now that I've run through, those are all of our possible options on here for reasons. We have to think about, okay, well, which one am I going to use to prove things? So since they're giving me this angle here, AEC, let's look at what is AEC made of. So AEC is made of AEB, this small one that's only blue, and then BEC, this one in the middle that's blue and red. So I'm going to rewrite this really quick, and I'm going to go the measure of angle AEB plus the measure of angle BEC. This is angle addition. AEC, it means the same thing as adding these two together. So I can definitely use that to break it up. Can I do the same thing with BED? Of course, because it has two pieces here. So BED is made of BEC, which is that shared one, BEC, plus the measure of angle CED. CED. All right, so now I've used or angle addition, so this is angle addition. That would be our reason if we do use this one. Will be angle addition. I'm going to get rid of that just for a moment so that I can kind of see between here. So now I want to start trying to separate out these ones. And remember, this is angle 2 and this is angle 3 over here. This is angle 1 and angle 1. So they have these angle measures also. Which actually, I didn't even think about that. That's a little easier to refer to instead of all this AEB and all that. Let's change that up just a little bit so that it's angle 2 plus angle 1. And then this guy is the measure of angle 1 plus the measure of angle 3. Oh my gosh, that's so much easier to look at instead of all those letters. So same idea, you can use these names in here instead of the angle measures. The reason they did that for this one is since it's including both angles, they can't say the measure of angle 2 and 1. They wouldn't say it that way. They just use the letters. All right, so now what we want to notice, and I forgot M here. It's not really too big a deal, but just for my plan. So now we want to notice that these guys are the same, right? I'm adding the same thing to 2 to get this angle as I am adding to 3 to get this angle. We already know the angles are congruent to each other. So if I know that AEC is congruent to BED, and I can rewrite these guys with angle addition, I can substitute this expression for AEC. And I can substitute this expression for BED. So we're going to use substitution. I'm going to substitute them together. And there's going to be an equal sign between them because there's an equal sign here. I'm just changing. If I know AEC equals angle 2 and angle 1 plus angle 1, then I can write angle 2 plus angle 1 instead of angle AEC. Same thing with BED. So I've substituted them together. And now what I want to try to do is I want to try to get just angle 2 and angle 3, right? That's my goal. So if I notice that measure of angle 1 and measure of angle 2 is on both sides, if we try to bring these together and I subtract the measure of angle 1 from the measure of angle 1 on both sides of the equal sign, what's going to happen to them? Anything minus itself cancels out or eliminates. It goes away. So I'm left with just the measure of angle 2 equals the measure of angle 3. Ooh, isn't that what I was looking for? It is. So again, I know it can be a little bit complicated, kind of the idea of planning it out, testing things, and sometimes there's more than one path. Definitely more than one way to see this. This is the way that I see it. So let's go ahead and actually put this in the proof here. So if I click send a proof for this one, it automatically puts the given in there for me and moves to the next step. If you type it in, you have to select given and then click the validate button. Validate lets you move to the next step. So it won't let you move to the next step until you choose the correct piece. And if I didn't put the given in here, I would not be able to put this next piece in, which is the measure of AEC equals the measure of angle 2 plus the measure of angle 1. It would not let me put this in if I did not do this first. Think of this as the socks and these are the shoes. Okay, I need to state, well, that's actually not true. I'm fibbing to you. They would let you choose this first. What it won't let us do is this equal step where we're substituting them together. This angle addition would work no matter what. So I could have put the angle addition in first if I wanted to. This is the difference between like when I was saying, does it matter if I put my socks or my pants on first? Nope, doesn't matter. So I was kind of fibbing to you there. So this one I could put in as soon as I wanted to, and I'm just doing angle addition. And I'm going to validate. I'm going to copy that because I'm going to use it on the very next one, but I'm going to change it to, go away. My stuff popping up here. BED, and this is going to be angle 1, whoops, and angle 3. And again, this one could have also, and I was just typing, they have to be typed in separately because each piece needs its own line. It doesn't let you put the lines together even though they're the same reason. So these two could have been stated before the given. It really wouldn't have changed anything at all. But what the given does is instead of AEC, I'm going to type in, because that's what this piece is, I'm going to type in this section here. Let's see if it'll let me do it. Like that. And then instead of BED, I'm going to type in this expression here, which is, sorry, no, I'm copying and pasting a bunch. 1 and 3, like that. So I have 1 and 3. And the reason here is I'm substituting. Remember, I'm taking this whole expression and substituting it for AEC because they're the same thing. AEC equals this. So I'm taking this whole piece and saying, well, instead of AEC, I'm going to write this. And instead of BED, I'm going to write this expression up here. So I'm using this step 1 down here for step 4. I'm rewriting step 1 using the separate angles. So I'm substituting those together, and I'm going to validate. So this step, this is the kind of the socks, and here are my shoes. I could not have said this step before these two. So those were dependent on each other. All right, so now that I have them together, my last step is to send this guy to proof. You don't actually see the subtraction happening on here. You don't see that step at all, but I'm using the subtraction, addition, subtraction properties, meaning I can subtract this or add, that's why it says addition or subtraction, but I can subtract or add the same thing from both sides of the equation. So that's what I'm doing. I'm subtracting angle 1 from both sides and it eliminates itself. So now when I get to this step and it says your proof is complete, now you can, click the check button and get your credit for it. So there's a lot of steps when we get to the proofs. So check. All right, so we are good to go. I know that was a little bit of a longer video, but we are through chapter 8. So I believe we are all done with section 8. I think we're all done with chapter 10, and I will see you in chapter 11.